on page 189, if you could enter the femur into list 1 and the humerus into list 2, please. Here we go. Now what we're going to do is we're going to do a stat calc 8, which we've already done, but we're going to do it. So we're going to go to stat calc 8. And you can scroll down to 8 or you can just hit the 8. Now, if you have a fancy smancy calculator, it will already have, it won't have this. Who has a fancy stuff? Yeah, you do. Okay. It's going to have an X list and a Y list. So this is Miss Flurry's version. Then this is your version. So if you have this calculator, when you hit it, you're going to do second 1. Then you're going to scroll down and you'll hit second 2. Frequent lists should always be blank. Store regression equation, don't do it. And then you're going to hit calculate. Okay? And you should come up with that. Now, if you have my calculator, you have to do it the old-fashioned way. Like you actually have to hit second 1, put a little comma in there, and notice that I came up with the same thing as the fancy smancy calculator did. See? Same thing. Okay? Now, what we're going to do is we're going to write the least squares regression line. Then we're going to look at it. You guys, you can do all of this stuff, right? Do all of this stuff without even graphing and still get and if you do not graph, you could get this problem wrong. You have to look at the graph. You can come up with the least squares regression line. You can come up with the correlation. You can come up with all of this stuff. But if you don't look at the graph and it's not linear, you don't see a line in there, it's nonlinear, then all of this stuff is out the window. Because remember, least squares regression line, if it's nonlinear, it's not going to work for it, okay? So now let's write this. So we're going to write it out normal. We're just going to write it with y hat equals a plus bx. So y hat equals a plus bx. Oh, that's right. I didn't give you enough room. Now we're going to put our numbers in. So x, so this is y hat. That's not x, y hat. So now y hat equals, our a was negative 3.6596. So I rounded. Does everyone see that I rounded? So negative 3.6596, because that 8 makes the 6 go up. Plus 1.1969x. That is a perfectly acceptable answer. And you'll get points for it. Yeah, you would get points for it. But you would never get 4 points for this. Okay? Remember, the AP exam is graded. When you answer a question, it is graded on essentially correct, partially correct, or incorrect. Right now, you are a partially correct answer, no matter what. Even though it's correct, you did not put it in context of the problem, therefore, they'll take points away. So, what are we trying to predict, right? We're trying to predict the humerus length, right? Is that what it says? Both bones, we're trying to predict the humerus bone. So this is humerus. It's not really humerus, but you get it. And this is the femur. That right there. And you guys, you can put humerus in, I think these are in centimeters. Humerus bone. This is the leg, this is the upper arm, right? This is the leg bone. So you can put humerus in centimeters, femur in centimeters. You can do that. But basically what you're trying to tell them is, I know I am trying to predict the humerus, that bone in the forearm, right? The bone in the arm, from the femur. That's what I'm trying to do. So that is how you would write it in context of the problem. Please notice that I still put the hat. because your line is a prediction line. So if I gave you a femur size, right, and you could predict it. So let's see if we can predict it. And then we're going to talk about slope in context of the problem. So you have femurs of 38, 56, 59, 64, 74. Let's do 60. Okay, we measured me for nothing. Because I don't even fit in this criteria. We're going to put 60 in for the femur. Okay. So 60 is a femur length. And notice it's inside that data. So right now, we're doing something called interpolating, okay? We're making a prediction with inside our data. That's interpolating, okay? If we would have used 31 or we would use 80, then that would be extrapolation. Okay, so what is the prediction of the humerus if the femur is 60? So if you're at home, we just picked 60. We just picked it. You missed all the stupid stuff that I did, but we ended up picking 60. We predicted that if this dinosaur's femur was 60 centimeters, its humerus would be 68.1544 centimeters. Okay? That's what the least squares regression line did. This is called interpolation. Now, we also can use it to predict, like they say someone with 38 should have a humerus of 41. So before the bell rings, let's do that one. So this is if I just give you a number. Someone says, hey, what would the prediction value, what would you say the humerus would be? So now we have an observed value. Let's see how well our line is doing predicting. So now we're gonna use this equation again, and we're gonna plug in the 38. That's the very first observation that they gave us. They say that the humerus should be 41. Well, let's see how well this line is doing predicting, because what we would like it to be is 41. Okay, do you guys have it? Mm-hmm. What did you get? 41.822. Not bad, right? So that's pretty good. That it's saying that our least squares regression line is doing a pretty good job of predicting. So that's what the least squares regression does. So tomorrow what we're going to talk about is we're going to talk about this slope in context of the problem. And then, so we've used our least squares regression to interpolate. Tomorrow I want to do extrapolation.